Hey folks, welcome to section 2.4. This is all about friction and spring forces. Friction is the more difficult part, so let's begin with that, and then we'll move on to springs. This video is about static and kinetic friction, two types of friction that arise in different situations, but are governed by the same equation. You will remember from the gravity equation that the absolute value symbol in an equation means that you're dealing with the magnitude. So the magnitude of the friction force is less than or equal to the magnitude of this quantity, and this is mu times the normal force. So that Greek letter is the Greek letter mu, and that is our symbol for something having to do with friction. So force of friction depends on two factors. The first one is called the coefficient of friction. Coefficient of friction. And that quantity is there to represent the roughness of the two surfaces. And so we remember from like Newton's third law that it takes two objects to have an interaction. And so in order for there to be friction, there has to be two surfaces that are sliding or attempt to slide relative to one another. The Fn is obviously the normal force. And that represents not the weight of the object, that represents something else this time. Represents how hard the surfaces are being pressed together. Okay, so friction depends on two things: how rough the surfaces are and how hard they're being pressed together. And each variable in that friction equation represents one of those things. Just to backtrack a moment, if I look at this equation, the units on either side have to be the same. Newtons is the unit for friction, newtons is the unit for normal force, and so in order for those two sides of the equation to have the same units, coefficient of friction has to have no units. So it's just a number. It's typically a number between 0 and 1, but it can go higher artificially if you like modify surfaces in specific ways. That represents the roughness. So the closer to 1, the more rough those surfaces are. So two types of friction. The first one is kinetic. Kinetic friction occurs when the surfaces slide relative to one another. That is different from rolling. Rolling is its own thing that we talk about later, but sliding, the surfaces have to be moving relative to one another. So at least one surface has to be in motion and the other one doesn't. If I like slide a box down a ramp, that kinetic friction force arises because the box and the ramp surfaces are moving relative to one another. Kinetic friction is, you'll see me use a lowercase f and then a subscript k. I know we use big F subscript little f up here for general friction force. Once we get into specific forces, I like to use the lowercase f for friction and then the subscript for either kinetic or static. The kinetic friction force is equal to the quantity of mu times the normal force. You'll notice that less than or equal to symbol is gone and replaced by an equal sign. And so that's like good news for us. Our model of kinetic friction is that kinetic friction is a constant force regardless of other factors. Obviously, if mu or the normal force changes, then the kinetic friction force has to change with it. But other forces that are acting on the object or the velocity or acceleration of an object doesn't impact kinetic friction using our model. Okay, so that's great. Static friction, not so lucky. Static friction occurs when the two surfaces are stuck together. They don't actually have to be stuck. In fact, most static friction examples that I give, the things are not permanently stuck together, but they appear to be stuck together. And so that means there is no sliding, but motion is possible. Static friction is when things stick together, and motion is part of the motion. Let me give you an example of when there's motion and when there's static friction. Um, Before we get to that, maybe we'll just go with no motion. If I set a box down on a ramp and it just sits there, well, static friction is responsible for the box not sliding down the ramp. However, when I walk around the room, static friction is essential to my success in walking. If not for my shoes and the floor sticking together, I would be sliding everywhere. And so that sticking process is important for me walking and also important for driving. If the tires didn't stick to the road and grip it, then my car wouldn't move. That static friction is really important. So there's two ways that static friction plays out. One is preserving this less than or equal to symbol. And so the magnitude of the static friction force is equal to the magnitude of the static friction coefficient times the normal force. And when we see this less than or equal to sign, we just mean that static friction is a variable force. So in other words, static friction is a response. So static friction responds to other forces. If I put a box on a ramp and it stays there, then that means that there is exactly enough static friction to keep it there. If static friction were any higher, then the box would accelerate up the ramp, which we hopefully know is impossible. So static friction is only, the magnitude of the static friction force is only enough to keep the box there, not to get it to move. If I were to increase the incline of that ramp, then the static friction force would have to increase with it, because as I increase that angle, the component of gravity parallel to the ramp is going to increase. And so static friction could respond to that. So the more applied force there is on an object that's not sliding, the larger the static friction force is to keep it there. However, there is some threshold, and that's the designation I have here is the maximum static friction force that is equal to mu sub s times the normal force. So this magnitude, mu sub s times the normal force, represents the maximum amount of friction that's possible. So the maximum force of friction that is possible for a given scenario. And so it depends again on the static friction coefficient and the normal force, but again, that is the maximum amount of resistance that friction can provide to prevent objects from sliding. If there's an applied force that is greater than this magnitude, then the object will start to slide and we will be in a kinetic friction situation. I will do a demonstration in class that will attempt to show you the difference between these two forces of friction, and so you might find yourself adding to these notes at some point, but that's it for now.